हेलो हेलो नमस्कार बच्चों, गुड इवनिंग एवरीवन। एक बार जल्दी से बताइए कौन कौन बच्चा आ चुका है हमारे प्यारे से सेशन में दोस्तों। और गेट 2026 अब आप सभी को पता है आ ही चुका है दोस्तों। और बस अब हमें क्या करना है, क्वेश्चन प्रैक्टिस करनी है, चीजों को रिवाइज करना है, रिकॉल करना है, जिससे हम अच्छा परफॉर्म कर सके अपने एग्जाम में। ठीक है, चलिए तो इस सेशन को शुरुआत करते हैं। अरे ये तो इंग्लिश पे, सॉरी सॉरी सॉरी, ओके। So this is English channel, so we'll conduct the session in complete English. Okay, so I welcome all of you to the great Wala channel, and now we'll be doing practice of mostly the focus of today's session will be mainly on the concepts of Bayesian network and the last topics of artificial intelligence. We'll also focus on other topics. Okay, so let's start the session. Namaskar everyone. So I hope all of you are working, all of you are studying with the full energy and with full dedication. Okay, so let's start. So this is my question number 1, alpha beta pruning, a most expected topic of the artificial intelligence. You can expect a question from here. Okay. Okay, now so here we can see that consider the following game tree with element of chance. Okay, so element of chance means both are possible. How many PYQs would be enough to perfect AI? PYQs. So PYQs are only for 2 years. We don't have much set of PYQs available. So obviously we don't have much PYQs available. Okay. One can also apply alpha beta pruning on this game tree. The number inside the chance node on the bottom row are the computed values of these chance nodes. What are the following? Which of the following statement is correct? Okay. So if the value of node G is greater than or equal to 0, then pruning will never calculate the value of node H. If the value of G is smaller than 0, then pruning will always calculate the value of node H. If the value of node G is larger or greater than 0, then pruning will always calculate. So we only have to work on this, that the value of G means the calculated value of this. So the value of G is greater than equal to 0, right, or less than equals to 0. Okay, so we have to work on this. G is less than 0, G is greater than 0. Okay, so let's try to see. This is your min node, this is your max node, okay, this is your max node. Again, this is your chance node. Chance node means it can go anywhere, it can go both sides. Okay, it will take the average of this. And what is this? The probability given, right? This is the probability which is given to us. Okay, so now let's start moving. So alpha equals to minus infinity, beta is equals to infinity. Okay, so it passes the value to this. Alpha equals to minus infinity, beta equals to infinity. It passes the value to this. Alpha equals to minus infinity, beta equals to infinity. So this is the max node. It will update your alpha. It will go to this, update the value to 5. Obviously pruning condition is not there, so it will go to 4. But it will not update alpha because alpha is already 5, more than 4. Okay, perfect. So right now we don't have any value assigned to this max node. Okay, so this chance node, I hope all of you remember what is the chance node. So chance node has probability of 1 by 2 and 1 by 2. So the value of the chance node will be 1 by 2 times the value of this node plus 1 by 2 times value of this node. Okay, so the alpha value is 5. It will transfer its value 5 by 2. We can say it's a chance node, so it will not update anything. Okay, it will give alpha equals to minus infinity, beta equals to infinity to this. Okay, now, so this is the max node. Again, it will go to 0 and 1. So this will be 1. And now the value assigned to this will be 5 into 1 by 2 plus 1 into 1 by 2. Okay, 5 into 1 by 2 plus 1 into 1 by 2, that is 5 by 2 plus 1 by 2, that is 3. Okay, so it will transfer back the value 3 to the min node. So min node will update its beta. So it will transfer this to this. Alpha is minus infinity, beta is 3. Okay, again it will go here. Alpha is minus infinity, beta is 3. Okay, now here we'll go to 4. Okay, so alpha will be updated to 4 and the pruning condition happens now, right? Because alpha is greater than beta. So this is pruned. Okay, so this value we get 4 and 4 will be transferred back to the chance node. Okay, now again we'll come back here. Now alpha is minus infinity, beta is 3. Now first of all we'll go to this g. So we don't know the value of g, what is this, but whatever the value is less than 0 or greater than 0. So here we'll get the value of g. Okay, so the pruning will happen only when pruning of this node will happen only when g is greater than 3, greater than equal to 3. The pruning will happen only when g is greater than 3. Okay, so pruning will happen only when g is greater than 3. Okay, all of you are able to do it, please check. Okay, so the pruning will happen only when g is greater than equal to 3. Okay, so none of these is the answer, none of the above. Okay, I hope all of you are able to do it. All of you are able to do it. A very beautiful alpha beta pruning question. Now let's see one more question. Consider the following game tree. Player 1 max node, choose the left action for which of the following value of z. What is z? X. I think X. So the okay, player 1 is a max node. These are min node. Then this is max node. Okay. So we want that player 1 should move left. Player 1 should move left. Okay, so player 1 should move left means this. So first of all, let's see. We'll take the maximum of this. Here we'll have the maxima of x and minus 9. Here we take the maxima of 9. So here we have minima. Okay, so the minima node will take the minimum of these two. The minimum of maxima of x comma minus 9 comma 9. Okay, okay, and what about the values here? So maxima node will give 1, maxima node will give 6, minima out of this, so minima is 1. Okay, now we have to choose the maxima node here. So maxima means we want to go to the left, so this is possible only when this value is greater than 1. This value is greater than 1. So minima of maxima of x and minus 9 comma 9 should be greater than 1. Then only we'll take the left path. Okay. So we can simply check the values. So if we take 2 here, if x is equals to 2, so obviously this will be minima of 2 comma 9 greater than 1. So you will say yes, yes it is. Okay. Second, if we take minus 7, then obviously if we take minus 7, then it will be minima of minus 7 comma 9 greater than 1. You will say no. Okay, so 2 is a correct answer. I think 4 will also be a correct answer, because if we take x is equals to 4, so maxima will be 4. So you'll say yes, yes it is. So I think we'll get the values. So 2 and 4 is the correct answer. Okay, all of you are able to do it? Please check. Okay, all of you are able to do it? 2 and 4 are correct. A and C are the correct answers. I hope all of you are able to do it. Let's move on. Now, let's see one more thing. Consider the following graph in which we are searching from start node A to the goal node J. J is the goal node. Start node is A. Okay. What is the number of nodes generated by iterative deepening search? Assume that the explored node is right to left order and all the edges are 1. So what are the number of nodes generated by iterative deepening search? So iterative deepening search is IDDFS or IDA star? Here we have to answer IDDFS or IDA star. What do you think? We'll answer IDDFS or IDA star. So this is iterative deepening search means IDDFS. Okay, IDDFS. Now, okay, so we'll explore right to left. So first we go to right, then we'll go to left. So first we go to right, then we go to left. So any options are there? No, no options are there. Okay, so in iteration number 1, it will only expand node A. In iteration number 2, the depth limit will change. We'll go to A to B, C, then to B, because only depth limit is 1. So we'll go to A to C, then to B. Okay. Iteration number 3, we go to A to C, then to G. Okay, because we are going DFS. So we then backtrack, then go to F, then backtrack, and then we'll move on like this. So A to C to G, then to F. I hope all of you are able to see this. Then back to C, back to A, then we'll go to B, then B to E to D, right? Okay. Now iteration number 4, we go to A to C to G to M. Okay. Then back to G to L. Okay. Then we'll go to F. Right first, so K. And then we'll move to J. All of you are able to see there's a very beautiful question. Very beautiful gate level problem. So IDDFS iteration 1 will move on to only the root node. Then depth limit is 1. So A to C to B. Depth limit is 2. A to C to G. Then F. Then back to B, E and D. So how many nodes are generated? How many nodes are visited in the process? So 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 nodes are visited. Please check. Nice. Nice. Okay. If you are able to do this question, it's a very beautiful question. I hope all of you are able to do it. Okay, so let's move on. I hope all of you are able to do it. It's a very beautiful question. Okay, which of the following statements are true? So means we have to check the equivalence. Here we have to say it is logical equivalence, means this and this has to be equal, means this is a tautology, then तभी ये true होता है, right? We all know that. So this has to be a tautology, then also this is true, then only it is true. Okay, here it is equivalence, and here we have implies. So let's see RS. So here we have a very lengthy question. Let's do it, a very lengthy one. So if we do option number 1, okay, option 1 is PQ, and okay, so only two variables are there, PQ 0 0 0 1 1 0 and 1 1. So this is not of P implies Q. So not of P implies Q. So P implies Q is true here. So this will be false. This is true here, it will be false. This is false here, but it will be true and then false. Now P or P implies not Q. So let's say P implies not Q. So P implies not Q means P is 0 here, so it will be 1 and 1. Not Q. So this will be 1 1, this will be 1, this is 0. Okay. So P or, so if we do P or, P implies not Q. Okay, so what is this? So this is 1 1 1, so this will be 1 1 1. P is also 1 here, so this is always true, but this is always not true. Are they equivalent? No. So are they equivalent? No. So I think option 1 is not there. So we can say, we can easily eliminate this and this. Now we only need to check third one. We don't need to check the second one. We don't need to check the second one. By option elimination, we can say first is false. So this and this will go. B and C will go. Only D will be available now. Only D we have to check. We have to check the third one, which is seriously a lengthy one. काफी lengthy है. Okay. So PQRS, we have 4 variables. And or and. Okay, so let's try to do it. Okay. So if this is true, this has to be true, right? It is the meaning of this. This is true, this has to be true. Okay, so let's try to do it like this. Okay. So if this is true, last one will be true. If this is true, then this has to be true. If this is true, this has to be true. So these are all and, means all of these has to be true, means P equivalent to Q has to be true, means we only need to consider the cases where P and Q are equal. We don't need to consider the cases where P and Q are not equal. Okay, so like this we can make our lives easier in this question. I hope all of you are able to do it. So we only need to consider where P and Q are equal. Okay, where P and Q are equal. Okay, so in this case this is true. Okay, fine. Now Q implies R. So Q implies R means let's say or R or S means both R and S cannot be 0. So obviously I think these lines will also go, because this has to be true means both R and S cannot be 0. So these lines will also go. Okay, now let's talk about Q implies R. So Q implies R means 1 0 cannot be the pair. When the Q is 1, R is 0. So this cannot be the pair. So 1 0 is also removed. Okay, now then what about this? Not of S implies Q. So not of S implies Q. This has to be true. Means there cannot be 1 0 pair. 1 0 pair means S, not of S is 1, Q is 0. Not of S is 1 means S is 0. So 0 0 cannot be there. S and Q cannot be 0. S and Q cannot be 0. So this is also gone. Okay. Okay. So these are the conditions where the LHS or this condition is true. Okay. P and Q are equal. Q and R is not 1 0. Q and R is not 1 0. R and S both are not 0 together. And S implies Q means not of S is 1 means S is 0 and Q is 0. So 0 0 SQ pair is also not there. So only these 4 combinations are there. Now when this is true, is S always true? Just check. If this is true, then is S always true? If this is true, then S is always true. So just check it. S is true, S is true, S is not true, and S is true. So you'll say no. This is also wrong. So only second is correct. Please check, all of you. It's a very beautiful question. And you can do that also. You can do that also. Okay, just do it like this. If LHS is true, RHS has to be true. If this is true, RHS has to be true. So this is true when P and Q are equal. Okay. Q implies R means Q and R. 1 0 pair is not there. Q and R. R or S. So R or S means R and S both cannot be 0 together. Okay. Not of S implies Q. Not of S implies Q means not of S is 1, Q is 0. So means S is 0 and Q is 0. Okay, just check dosto, all of you are able to do it. Done it? All of you are able to understand the concept, a very beautiful one. Otherwise, this would have been very lengthy. Okay, this would have been very lengthy. Okay, we have done. Let's move on. A very beautiful question. Let's see how many of you are able to do it. Please try to do it. Okay. Which of the following formulas correctly formalize the sentence Which of the following formulas correctly formalize the sentence every graph that is acyclic and has no isolated vertices is connected? Please check. Every graph that is acyclic and has no isolated vertices is connected. Okay. So let's try to do it. Every graph means for all x that is acyclic and has no isolated vertices is connected. I hope this is correct. Please check. Is the option A is correct? Please check दोस्तों. All of you are able to see A is correct. For all x is acyclic and not isolated vertices implies that it is connected. Is this fine? Okay. What about the second option? Is B also correct? Please check. Is option B also correct? What about option B? Please check option B. So option B says if we don't look at not, okay, we look at least there is a x, at least there is one x which is acyclic and no isolated vertex and not connected. What about option B? So at least there is one x. At least there is one x. At least there is one x. ध्यान से सुनिएगा second option. At least there is one x which is acyclic and no isolated vertex and is not connected. So we are talking about negation of this. At least there is one x. At least there is one x. At least there is one x which is acyclic and no isolated vertices and is not connected. Okay. So what about this? Option B is correct. Okay. So in the option B we are saying if we remove this not, we say that at least there is one x. At least there is one x which is acyclic and no isolated and is not connected. At least there is one x which has this and is not connected. But we are negating that. Means we say there is no one. We are negating this. We are negating this means we are saying at least there is one x. Now we say there is no x. We are negating this. So there is no x which is acyclic and no isolated vertices and is not connected. So there is no x which has these properties. So does it mean this? Does it mean this? Does it mean this? Yes. Just think about it, please. So in option A is directly correct. Option A has no issues, but let's see option B. So option B, if we remove this not, we say that at least there is one x. At least there is one x which is acyclic and not isolated and is not connected. Acyclic, not isolated and is not connected. There is at least one x which has this property. But if we negate this, then we say there is no x. There is no x which is acyclic and not isolated, and is not connected. Okay, so option B is also correct. Please check. All of you are able to do it. Please check. Okay. Done it? All of you are able to do it? Let's move on to the next question. Okay. So we are moving from left to right. We have to apply alpha beta pruning. Now, which of the following nodes will be will be pruned in this process? How many nodes will be pruned in the process? Namaskar. Hello. So let's start with this. Alpha is minus infinity, beta is infinity. We'll move on to this. Then this. We can say this is our max node. Alpha is minus infinity, beta is infinity. So alpha will be maxima, that is 42. So minus infinity, beta is 42. We'll give this. Alpha is minus infinity, beta is 42. Okay. So first of all, we'll go to this 25, then we'll go to 11. So obviously alpha value will be 25, and we'll transfer this 25 back. Okay, we'll transfer this 25 back, and obviously beta will be updated to 25. It will go back. So alpha will be updated to 25. Okay, so alpha is 25, beta is infinity. Alpha is 25, beta is infinity. Then we'll go to this. We'll get alpha 33 and 29. So we'll update this to 33. Okay. Then the value will go back, and it will update beta to 33. Then it will go here. Alpha is 25, beta is 33. Then it will update its alpha. It will say no updation required. Alpha will be 14. I think no pruning is there. Let me do it again. Check kar leta hu. Alpha is 42. 42 will go back. Alpha 25. Okay. 25. Alpha is 25. Beta is infinity. So alpha will be 33. 33 will go back. 33 and alpha. Okay, I think no one is getting pruned in this case. Hai na? Let me do it one more time. I'm not getting anyone getting pruned. Okay. So alpha is minus infinity, beta is infinity. It will give the value to this. Alpha is minus infinity, beta is infinity. Alpha is minus infinity, beta is infinity. Okay. So it will go to this 18 and then 42. So alpha will be 42. 42 will go back. It will update its beta. Okay, because it's a min node. So it will update its beta. Beta will be 42. Alpha minus infinity, beta 42. It will go to this 25 will be the alpha value, or 11. So it will take a 25. So 25 will go back. It will update its beta 25. It will update this. Alpha will be 25. So alpha is 25. Beta is infinity. Okay. Then it will go here. Alpha is 25, beta is infinity. It will go here. It will update its beta. Beta will be 20. Alpha will be 33. Okay. So it will go to this. Alpha remain 33. 33 will go back. It will update its beta 33. I think no one is getting pruned, na? Ha, no one is getting pruned. I'm correct. So none of the above. None of the above. So no one is getting pruned. Okay, so I think the answer is getting verified. I hope all of you are getting the same result. No node is getting pruned. Okay. Okay, so let's move on. I hope all of you are able to do it. Okay, a very beautiful set of the questions. Okay, the heuristics value are written on the node and the path cost is also mentioned on the edges. A star search algorithm is applied. Okay, so before moving to the goal node, which of the following node will get visited before reaching the goal node? Okay, so let's try to do it. We start with the start node. Start node, then ABC will enter the open list with the cost of heuristic value 9, path cost is 6, 15. Heuristics value 7 and 5, 12. Heuristics value 6 and 11, 17. Then we'll move on to, obviously we'll move on to B. B will take us to E and D. Okay, what about E? So we can see the path cost is 5, 3, 8 and 4, 12. D is 5, 7, 12 and 5, 17. So we'll go to E. E will take us to A or F, both. So it can update F also and A also. It will update A like this: 5, 3, 8, 4, 12, 12 and 9, 21. A will say no, I am happy with 15. F 5, 3, 8, 2, 10 and 12. Okay, 5, 3, 8, 10 and 12. Perfect. Then again we'll go to F also, only because we can say the path, the cost is minima. So F will take us to D also and G. D and G both. F will update D and G both. 5, 3, 8 to 10, 10, 5, 6, 16 and 5, 21. It will update D to 21. It will say no, I am happy with 17. 5, 3, 8 to 10 and 11. Okay, so we can say that we'll move on to directly G. So before moving to G, which node is visited? So we can say that this is the sequence in which we are visiting: S, B, E, F, G. Okay, all of you are able to do it? Okay, so let's move on. Let's try to do this question, a very beautiful one. X is an even number. X is divisible by 3. X is 10 to 20. This is your, I think, PQRS. P, Q, R and S. Okay. The integer which satisfy this means which make this true. So it is Q and not P. I think ये not तो नहीं. I think this is not outside. Q and not P implies R implies S. So we have to make this false. We have to make this false. Because if this is false, then overall will be true because this is a negation sign. So we have to make this false. This is false only when this is 1 and this is 0. So Q and not P should be 1 means true. It means Q should be 1 and P should be 0. And R implies S should be 0. This is possible only when R is 1, S is 0. So P is 0 means false. Q is 1. R is 1. S is 0. Means the number is from 10 to 20. It is not an even number and divisible by 3. It is not a perfect square. What is the answer? Just check this one, dosto. This kind of question was a PYQ in computer science. So we can say this whole term should be true, though. So the term inside the bracket should be false. Means this is true, this is false, this is 1, this is 0. Then only this can be false. This is 1 means Q is 1, P is 0. And this is 0 means R is 1, S is 0. So PQRS, the combination will be like this. Okay. So 0, 1, 1, 0. 15 is the number. Bilkul sahi hai. This is perfectly fine. So we can say 15 is the answer because it is not an even number. It is divisible by 3. It is 10 to 20. And it is not a perfect square. All of you are able to do it. Please check. Okay, is this fine? Let's move on. Okay. Okay, so we have the heuristics value written and the path cost is also written. The heuristics value, let me write. So these are 42, 30, 20, 18, E is 20, F is 16, H is 9 and 0. Okay. So they are asking how many nodes are admissible and how many are consistent. So first of all, let me check what are consistent. So heuristic value should be less than heuristic value of the consistent. Let me check what are consistent. So heuristic value of the node should be less than equals to the heuristic value of the neighbor node plus the path cost. Okay. What about this A? So heuristics is 20 and 7. 27 is the path and heuristic value. The heuristic is 42. So this is not consistent. Okay. So this is not consistent. What about 30? So what about B? So B we can say it is 20 and path cost is 11. 31 less than greater than 30, so it's fine. What about this? 15 and 18, obviously 30 is less. 11 and 42, 30 is less. So 30 means B is consistent. What about D? 10 is the path cost, 20 is heuristic, so this is fine. 42 is the heuristic, 14 is the path cost, so 20 is fine. So D is also consistent. What about C? Okay, so heuristics is 30, path cost is 20. Sorry, heuristic is 30, path cost is 11, and iska heuristic क्या है? 20. So this is consistent on this path. Heuristics is 42, neighbor node, path cost is 7. So total is 49. This heuristics of this is 20, so obviously valid. Heuristics of this is 20, path cost is 10, and the heuristic of this node is 20. So obviously it is less than the heuristics plus the path cost. So this is also consistent. No, we have to check more. The path cost is 8, heuristics is 18. So obviously sum is greater than 20. So this is also fine. Path cost is 8, heuristics is 16. So obviously this is also fine. So this is also consistent. Now let's see this one. Heuristics is 30, path cost is 15, obviously more than 18. Perfect. Heuristics is 20, path cost is 8, 18. So obviously this is perfect. The heuristics of the node should be less than the path cost plus heuristics. Heuristics of the node, that is 18, should be less than 9 plus 16. Perfect. Heuristics of the node should be less than equals to the path cost and the heuristics. So this is also perfect. Now, what about F? So heuristics of the node 16 should be less than path cost 20 and heuristics 0. Perfect. 16 should be less than 9 plus 18. Perfect. 16 should be less than 8 plus 20. Perfect. So this is also consistent. What about H? Heuristics of the node should be less than path cost 10 plus heuristic 0. So perfect. Heuristics of the node 9 should be less than path cost 9 plus 18. Perfect. Okay. So this is also perfect. So all the nodes are consistent. Only the problem is A. So how many are consistent? This is not only 1, 2, 3, 4, 5, 6, 7. So 7 nodes are admissible, consistent. Are you able to see this? A very beautiful question. Since there is no direction in the graph, we'll consider all as neighbors. So if we are checking B, we'll consider every neighbor, E and A, everyone. When we are calculating C, we'll consider E, F, D, B, all as neighbors. So we'll check everywhere. This is fine. What about admissibility? Let's check about admissible. Okay. So what is the shortest path we have? So we can say the shortest path is 10, the cost is 9, admissible. Shortest path is 20, cost is 16, admissible. Shortest path from E is 9 plus 10, 19, cost is 18, admissible. From C, what is the shortest path? The shortest path is 8, 9 and 10, because we cannot go like this. 8 and 20 is 28. 8, 9 and 10 is 27. So this is the path. 27 is the cost. Heuristics is 20. So this is also admissible. Okay. What about B? So B, we can say the smallest path is, we'll go to C, then we'll go to E. No, this will be longer one. So we'll directly go to H, E. 15, 9 and 10. So obviously the cost is more than 30. So this is also admissible. Okay. Now from D, what is the correct path? 10, 8, 9 and 10. So 10, 10, 20, 28 and plus 9. So this is path cost is 20. So this is also admissible. What about A? The heuristics is 42. What is the path cost? So path cost will be smallest is, we'll take 7, then we'll take 8. 7 and 8 is 15. 15 and 9 is 24 and 10 34. So cost is 34, but heuristic is 42, so this is not. Rest everyone is admissible. So we can say here, how many are admissible? 7. Okay, so total 14 is the answer. Please check everyone, all of you are able to do it or not. Okay, all of you are able to see this, please check. This can also be true, because if it is consistent then it is admissible. That's perfectly fine. We can check only A. A is also failing. That's perfectly fine. Thank you, Krishna. This is perfectly fine. So if the node is admissible, then it has to be consistent. So 7 are admissible, 7 has to be consistent. We only have to check A. So A is failing. So 7 plus 7 is the answer, 14. Is this clear to all of you? Okay. So we'll end the session at this question. We'll meet you at 9:30 on our Hindi channel for Maha Abhyas, and we'll solve the questions related to mostly related to and mainly related to Bayesian network and variable elimination techniques. Okay, so we'll continue from this point.